So to finish this up, we'll look at how you do matrix equations. Okay, and you're going to do this on the calculator. You're going to get the answer on the calculator, but mainly what I want to see that you can do okay is set these things up. So here's the system of equations. If I say set up a matrix equation, that's different than an augmented matrix. So the first thing you do is you write down the coefficient stuff, okay? So your first matrix would just be 2, 4, 2, 4. That fact that those numbers are the same tells me something too. Okay, then you just close like that, okay? Then what you do is you do a variable matrix. So next to that you would have x1 and x2. Okay, and you're multiplying those two things together like that. Okay, then what you're going to have is what they're equal to. Okay, so what they're equal to is 6 and 12 like that. So if I want you to put together a matrix equation, that's what I mean by that, is to do that. Okay, all right. So now what we do is when you solve a matrix equation, this is what you basically do. You don't have to show the steps on this. The result of the matrix equation, this will show you what you put in the calculator, is you say x1, x2, then you put the first matrix, 2, 4, 2, 4, and then you do the inverse of that, because we're talking about inverses, and then you multiply that by 6, 12. Okay, we're kind of talking about really the y part of that, but anytime that I want you to do a matrix equation, it's just set it up like this. It's always the same. And then this is always going to be that inverse times that, in that order. Don't get that order backwards. Okay, now let me see if you know this or not. We talked about this last week. Look what happens when you multiply the diagonals. 2 times 4 is 8, 4 times 2 is 8. Does that tell you anything about that inverse? Okay, you probably forgot. Okay, if the diagonals are the same, 2 times 4, 2 times 4, that's a singular matrix, so that inverse does not exist. So, and I'll show you what will happen if you put this in your calculator, and you want to know this so you can save yourself a bunch of time. This does not exist. That's what we call a singular matrix, so it does not exist. The inverse can't be done this way, and that's just because 2 times 4 is equal to 2 times 4. If the diagonals have the same product, then you can't do that inverse on your calculator, okay? Now that doesn't mean that we can't solve this problem. It just means we can't solve this problem with a matrix equation. So you want to write on there that you can't solve this problem with a matrix equation. So we're going to have to try something else, okay? If that inverse did exist, then we would just put that in our calculator and we get the answer, okay? And we did, I think, one of those last time. We'll still do a few more of those today. So this is what you want to do instead. Forget the matrix equation. What we're going to do next is we're going to put a augmented matrix in our calculator. So essentially there's 2 main methodologies I've taught you with matrices. There's the augmented matrix in reduced row echelon form, and then there's the matrix equation. Okay, so just write down your augmented matrix. That would be 2, 4, 6, and then 2, 4, 12. And we're going to put that in the calculator, and we're just going to do reduced row echelon form. Okay? All right. So let's put this in our calculator. I hope you guys are getting okay with your matrix on your calculator. That's going to be a big deal for your test next week. So again, we open up the matrix command. You can put it in any of the matrices you want. I'm just going to put it in matrix A. What's the size of the matrix I'm putting in? 2 by 3. Okay, it's got 2 rows and it's got 3 columns. So you want to get that set up. Then just put in the first row, which is 2, 4, 6. Okay, like that. And then the second row is 2, 4, 12. Okay, now you want to do that in a reduced row echelon form now. So what you do, clear the screen. The quit button clears the screen, so you can go second quit to clear, and then go back to the matrix command, second x -1, nope, not that, second first, like that, and then get the matrix to come out, and then go to math, and then go down to where it says reduced row echelon form. Okay, we've done this quite a bit. So you get that highlighted, okay? Then you put in your matrix A. So you got to go back to the matrix menu, highlight A, do that. Now press enter, and then that will tell us what kind of answer we have. Okay, so we want to write down what this result is. So that result from the calculator is 120001. Okay, so you want to get to a point. There's basically three things that can happen on this. If you have it, let me see if you remember this. What happens if you have a row of zeros? That's infinite solutions. How about this? 0 plus 0 equals 1. What does that tell you? No solution. Okay? All right. So that's it. This problem has no solution. What it means is the lines are parallel. If you went back and graphed these two equations, they would be parallel. Okay? I don't need to know that they're parallel, but that's what would happen geometrically on that. Okay? So it has no solution. All right? So that would be how you do this. Now, you guys are always going to do the reduced row echelon form on the calculator. You're not going to be required to learn how to do that outside of a calculator. And the same thing with a matrix equation, you're going to do that on a calculator. Okay, let's do the next one, I think, together here. And then I'll let you maybe do the one on the next page on here. But just since we're kind of remind you what's going on, let's just do this one together. Okay, so on this one, what you want to do is go ahead and just write down your matrix equation. So we're going to try to do this one by matrix equation. So the first thing you do is you do what we call the coefficient matrix. So you just write down, you have 2, 1, 5, 3. That's your first matrix. Okay, then you multiply it by your variable matrix. In this case, it's x1 and x2. If you had 3 equations, it would be x1, x2, and x3, and so forth. And then that's equal to 2 and 13 like that. Okay, so like on your exam and everything next week, if I want you to write a matrix equation, that's all you do. And if you solve it, you need to just write down what you're going to put in your calculator. So the solution goes like this. You would have x1, x2 equals, then do the inverse of the coefficient matrix. So you write that and put the -1. That represents that it's an inverse. And then times the 213. And don't do that backwards, because you'll get a different answer if you do the 213 times the inverse. So you got to do this in this order. Okay, now we're going to put this in our calculator. So I'll show you what to do on this. If you're getting comfortable with your calculator, then let me just kind of put this over at the side like this then. Okay, so what you need to do is, this matrix is a 2 by 2 matrix. I'm going to put that in matrix A. This is a 2 by 1 matrix. I'm going to put that in matrix B. So you need to go ahead and get those two matrices set up, and matrix edit. And let's see, I'm going to, matrix A is a 2 by 2. I'm going to change it. And you can set up these, put these matrices in any one you want. So this is just going to be 2, 1, and then 5, 3 like that. Okay, so that'll give you your matrix A. Then you want to go to matrix B, so you have to just start over again. You can go quit to get to a clear screen, and then back to the matrix command, and then to edit, and now I'm going to put the second one in matrix B. Okay, so if you press enter, you want to put the size. This is the 213. That is a 2 by 1 matrix. So you put that in, put the numbers in, which is 2 and 13 like that. Okay, so if you've got down how to put your matrices in now, that's the big part of the problem, is just getting those matrices in. Now what you're going to do is you're going to do this on a clear screen. All right. So what you want to do is, once you get your screen clear, you want to go back to matrix, highlight A and press enter. Then do the -1 key. This X -1 key is where you do the inverse. So it's going to do the inverse for you. And then we can do times matrix B like this. Okay, just highlight B and do that. That's what you ultimately want to get on your calculator. Now let me ask you a question on this. Is this matrix going to exist? 2 times 3 is 6. 1 times 5 is 5. Okay, yeah, you're not going to have a problem with a undefined inverse, and after you just press that, it'll give you the answer to the problem. Okay? All right, so let's see what we end up getting here. So what you're going to end up getting on this then is this is equal to negative 7/16. All right, so what does that mean? What does the negative 7 mean? That is what? That's x1. What is the 16? That's x2. Okay, so if you did this same system of equations by like substitution or elimination, the way we did it before we learned matrices, that's what you would end up getting for your answer then. Okay, so that's ultimately what you put in your calculator to solve a matrix equation then. All right, are you with me? Okay. Okay. I want to show you one other thing. There's one other thing I want you to just do real quick on this problem, because I want to remind you that even though your calculator is going to do this right, the meaning of this problem is if you took the original first equation and plugged in negative 7 and 16, you'd have 2 times negative 7 plus 16, that's equal to 2. That checks in that first equation, in other words. If you plug it in the second equation, you would have 5 times negative 7 plus 3 times 16 equals 13. Okay, they're both right. You can verify that on the calculator, but you have the ability to really quickly tell that you have the right answer on these problems. Okay, everybody understand that? Okay, you can always check on these things, plug in, see if they work in both equations. If they do, you know 100% that you are right. Okay, any questions about what I did? Yes or no? Okay, let's go to the next one. I want you to do this one on your own. So write down the matrix equation, get your calculator out and see if you can solve that and see if you get an answer. Okay, it could be no solution possibly on this. Could be infinite solutions. You'll just have to put it in and see. So go ahead and kind of get everything written out. While you're doing that, I'm going to get everything put in my calculator. So when I do this on an exam, you know, this is the way I'll have you do this, is just write down that you set up your matrix equation okay. And that's real easy, nothing to that. You just want to make sure you know how to put that in. And that will be one of the matrices that you're going to put in, is that coefficient matrix. And then your second matrix is going to be x1, x2, x3 like that. And then that's equal to the 1, 3, 2. Okay, that's your matrix equation. That's real easy to learn how to do. Now your matrix equation, what you do when you solve it, you're going to end up with x1, x2, x3
And what you do is you do the inverse of the coefficient matrix. So you just write that as 1, negative 2, 3, 2, negative 3, negative 2, 1, negative 1, negative 5, inverse, like that. And then what you do on that is just multiply that by the other matrix, 1, 3, 2, like that. Okay, so I mean, that's what I want you to be able to do. That's all that you have to write on your paper. The rest of this you're going to do on your calculator. Okay, so what I did on this is I put in matrix A, that's a 3 by 3 matrix. So I put that information in A. This is a 3 by 1, so I put that information in. Then I'm just doing A inverse times B, okay? So let's see what we get on that when I put that in the calculator. I've already got everything in the calculator, so if you've got everything in and get to this point, you're going to get this, okay? Now, you wouldn't know that's a singular matrix, so what's going to happen is we have to do this problem in a different way, okay? Those of you who tried to do that get the same thing, okay? And you can't really tell on a 3 by 3 whether it's singular. You can't do that thing with the diagonal. So what would happen on this is you would just have this result. You would say that you can't do this with matrix equation. It's kind of like that problem I did just a few minutes ago. So you can't do with a matrix equation. I still want you to solve the problem. So what would you do? Go to the augmented matrix and just do that. Okay, so what we're going to end up doing is we're just going to do the augmented matrix and start over again. Okay, so you basically, your calculator gave you that that's a singular matrix. That doesn't mean that the answer is no solution. It just means that you don't have an inverse of that matrix. You can't do that, so you have to do it the other way. Okay, so when you do this, you would go, your augmented matrix would be 1, negative 2, 3, comma 1, and then 2, negative 3, negative 2, 3, and then 1, negative 1, negative 5, 2, like that. So you're just going to put that in your calculator, start over again, and then just do the reduced row echelon form like that. Okay? All right? Now, like on a test, I'm not going to give you a problem, a matrix equation that you can't do it with, because that's kind of like a waste of time. So I'll give you something more like that first one I gave where you'll get an answer to it. So with this one, you just start over again. I'm going to put this in matrix C this time. And I've got a 3 by 4 matrix that I'm going to put in. So I just put in the 3 by 4, the augmented matrix. So the first row is 1, negative 2, 3, 1. Second row is 2, negative 3, negative 2, 3. Okay, and then the last row is 1, negative 1. Oops. Okay, negative 5 and 2. Okay, so you want to get that matrix put in. That's your augmented matrix. Okay, and I'm just going to slide this kind of over at the side there. And then what you do is you go to the reduced row echelon form. Okay, so has anybody done that yet? Did you get an answer?
Yes.
Okay. It was, what was it, no solution? Infinite solutions. Okay, so let's finish that up then. Okay, whoops, there's something wrong here. Okay, so I got that put in, and then let's write down whatever result came out. So I put this in matrix C is what I did. Okay, so let's see what we get. So you got a row of zeros. Does that look right? Okay. So you want to write that on your paper then. So what we have is 1, 0, negative 13, 3, 0, 1, negative 8, 1, and then 0, 0, 0, 0. Okay, now this is the thing that I think some of you have asked me a lot of questions about, like in the Math 93 today. It is infinite solutions, but I don't want you to just write that. I want you to use the parameter thing, okay? So let's watch this real carefully. It's not that hard once you catch on to this, but this first equation, what it says is it says x1, then you have a 0, so you don't pay attention to that, then it would be minus 13x3 equals 3. That's what that first row says. The second row says x2 minus 8x3 is equal to 1. Okay, now you basically decide what you want t to be equal to. Generally on this, if the same thing shows up twice, like x3 shows up twice, that's the ideal thing to let t be equal to. So this is essentially what you do. What we're going to do is we're going to let x3 be t. Anytime you have infinite solutions, you got to do this thing we call a parameter. Okay? Then the first equation is now going to be x1 minus 13t equals 3. Again, I'm just plugging in t where x3 is. Now solve this equation for x1. If you do that, you're going to get x1 equals 3 plus 13t. Okay? You're going to write your answer in terms of t. The second equation is x2 minus 8x3. What do you do with the x3? That's t, right? Okay, that's equal to 1. Okay, then what you do is you solve this for x2. So you would get x2 equals 1 plus 8t. So you have a couple of ways you write the answer. One way to write the answer is just those three things there. Just tell me what they are. The other way is to write this as a point. x1, it comes first, so that would be 3 plus 13t. x2 comes second, that would be 1 plus 8t. And then x3 would be t, like that. So that's how you do that. Now what you have to do anytime you have that row of zeros is write down what each equation means. If you have something showing up twice, that x3 is going to be your t. And all in the world I'm doing is just replacing x3 with t. That's it. Okay? And what this gives you is t can be any real number. So if you wanted to get specific solutions, you would just pick a number for t. Like if you picked 1 for t, then you would just plug it into each place and you would get one of the solutions. If t is 2, you plug it in and get a second solution and so forth. Does that make sense? Okay, that's what you do when there's a row of zeros, and I want you to do what we call parameterizing. That gives a general formula that generates all those solutions. That's the idea. Any questions? Okay, how do you know to do this t thing? Let me ask that question. There's a row of zeros, okay? All right, it's always the same, all right? Infinite solutions. Okay, let's do this word problem. We're going to do this with matrices on the calculator. This kind of shows you, hopefully, the benefit of doing this in a business context is matrices can be done pretty fast, okay? So we're going to do mainly the setups of these things. And let me read what this says. So this says that the parking fees are $5 for local residents and $7.50 if you're not a local resident. And at the end of the day, they've kind of given you this table here. This would be like day one. This just basically says 1,200 total cars were parked in the parking lot, and you made $7,125. This is another piece of information. You're actually going to have 4 systems of equations on this. This says on the second day, you had this many cars parked, and this is how much money you made, okay? So what you want to do on this is x1 is just going to be the number of local residents, okay, that parked, okay? You have 2 variables. You have 2 parking fees. So that will be the number of local residents, okay? And those are, remember, that's $5 per car is what that is, okay? x2 is going to be the number of other residents. And you can just kind of abbreviate some of this stuff if you want to. And then that was $7.50 each, like that. So you've got to identify what the variables are on that. And that comes from the question, how many vehicles in each category were parked that day? Okay, that's what the problem says. All right, now let's see if we can come up with a system of equations for each one. Okay, the first thing is, and we're just going to look at day one first of all. Okay, let me just ask you guys a question. What would x1 plus x2 add up to according to my chart?
Total 1,200.
There you go, 1,200. That's what it is, okay? The number of cars that are parked is 1,200, right? Okay. How are you going to make an equation that represents this money, though? Okay, X1, how much does X1 cost? $5 each. So you would say 5X1, and then X2, those cars cost $7.50 each. So you'd go like that, and then that would be the total amount of your money. That would be $7,125. So that's a system of equations. And the nice thing about doing this stuff with technology and matrices is you could program a computer to run through this real fast for you to get all this taken care of. Okay, so what we're going to do is we're going to basically just do the results for each day, but all we got to do is get one matrix set up, and we're going to do reduced row echelon form because that's generally easier than a matrix equation. So let's just put this in our calculator, 1, 1, 1200, and then 5, 7.5, and 7,125. So that basically is the system that's going to solve that problem for day one. So what we're going to do, and we're just going to set up one matrix on this, and we can kind of type over it for each day when we do this. So I'm going to go to matrix. I'm going to put this in matrix A, and we'll do this in reduced row echelon form. Okay, so this is a 2 row by 3 column thing. So you want to get that put in 2 by 3, and then the numbers are 1, 1, 1,200, that's the total number of cars that are parked is 1,200. And then the second one is the cost, $5, $7.50, and the total receipts from that is 7,125. Okay, like that. So what we're going to do on that is we're just going to go through and put this in reduced row echelon form, okay? So once you get that put in, you want to just do the reduced row echelon form for this. Okay, and then we're just going to do we'll be able to type over this for the other ones pretty quickly. Okay, so I just put that in. Okay, reduced row echelon form on that. So this particular one on day one, you're going to end up getting this. You're going to get 10750, 01450. Okay, so tell me what the 750 means. That's how many of the cars parked that cost $5. What's the 450? That's the 750. Okay, so what you would have out of that is you would just have 750 of the local, and then you'd have 450 of the other. I'll say it's real fast to put that together like that. Okay, does that make any sense to you? Okay, all right. Now what we're going to do on the next ones is we're just going to get the answer on the next ones. You don't have to write anything down other than the answer because we've already got the matrix put together. So it's going to basically go like this then. So you're just going to type over it. So for day two, I'm going to go back to that same matrix I have. The only thing that's going to change is you're going to end up having 1, 1, but now it's going to be 1,550. So now you got 1,550 cars parked. The second row is the same. We didn't change the fee on that, but the amount of money we made was $9,825. Okay, so the benefit of doing this, you can just type over everything real quick. Then we're going to put that in reduced row echelon form. Okay, so I go back to clear screen, reduced row echelon form, and then we'll see what we get for this. Back to matrix A. Okay, so the second one, day two, the result is, and all I want you to do is just write the matrix, 10720, 01830. Okay, so that again means 720 local residents, 830 others, like that. Okay, and that's the idea. Okay, all right, I'm going to do the next two. I want to go ahead because I'm not sure what will happen on all of these if they all have solutions or not. So I'm just going to type over the next two, and you can do the same thing. You can just type over what we already have. Okay, so the day three, the only thing that would be different is you've got 1,740 cars parked. Okay, then we've got, let's see, the amount of money was $11,100. Do I have that right? Yeah, 11,100. Just do the same thing, clear screen, row echelon, reduce row echelon form. And we'll see if we get an answer or not. We may or may not, just depends. Okay, so we got a different combination. All right, so day 3, I think I'll just stop at day 3 and go to the next problem, because you should get the idea of what I'm doing. Okay, so that's day 3. Again, that would be the number of local residents, and then the 960 would be the others. Okay, does anybody have a question about what I'm doing with the matrix to solve that problem? Okay. Okay, well, let's do this second one. I'm going to worry about day 4. You probably would just get a different combination on that possibly. But part B, what it says is this. It says we're going to have 1,200 cars parked, and it says, is it possible to make $5,000 out of that 1,200? So what you would do on this is your matrix would go like this. It would go 1, 1, 1,200. Then it would still be $5, $750, and 5,000. So we're going to put that in the calculator and see if that's possible. Then the other thing we're going to do is 10,000. We're still going to do 1, 1, 1,200 cars parked, then 5, 750, and then 10,000 like that. So let's see if it's possible, and let's see what the calculator tells us then. Okay, so I can actually just type over what I have on the same matrix, so we don't have to worry about setting up a brand new matrix or anything. So we're going to have 1, 1, 1,200. Okay, then the last one, 5, 7.5, and then we're going to see if it's possible to have a combination where we make $5,000 off of that. Okay, so you put that in your calculator, and you would do that in reduced row echelon form. So let's see kind of what we get on this, and then I'll see what if this makes sense to us. Okay, so here's what we get. Okay, is that possible? No, what's wrong? You'd have negative cars, right? So that doesn't make any sense. Okay, so what's happening on this in your calculator, you want to just write down you're getting 1, 0, 1,600, 0, 1, negative 400. Well, that's not possible. It's not possible if you understand the context of the problem, because you can't have negative cars, okay? So that's not a realistic possibility. We're going to do the next one the same way, and let's see kind of what happens on this next one. Okay, I'm going to edit that same matrix again. All I really need to change is the 5,000 to 10,000, then we'll see if this comes up with anything that's possible or not. Okay, and I just do this in a reduced row echelon form. So go math, reduced row echelon. Okay, put in the A, and let's see what kind of result we get on this. Okay, is that possible? Same idea. Okay, so this one's not possible either. That's just you can't have negative numbers of cars. So it just kind of did this in reverse, really. So again, that one is not possible because of that. Okay, so you can answer a lot of questions using a matrix calculation. And if you can set up the word problem okay, then it's a matter of applying matrix algebra to it. Yeah.
It says explain. If on the test it says explain, can we just circle the negative like we did here?
Well, you would just say it's impossible to have negative cars.
Okay.
Okay. If you circled the negative, I might not know what you mean.
Okay.
Okay. All right. So it's not possible because of the negative cars. Okay, so that'll take care of that. We're going to go ahead and get into